Hello grade 12s, and welcome to the next video from the answer series. In this video we will unpack the idea of power in mechanical systems, develop formulae for power, and use them in calculations. Power is a rate quantity. All rate quantities are something divided by time taken. Think velocity, rate of change of position. It is displacement divided by time taken. In electricity, power is the rate of energy transfer. Energy transfer divided by time taken. In mechanics, power is the rate of work done. Work done divided by time taken. Work done and energy transferred are equivalent and have the unit of joules. The unit for power is then the joule per second, more usually known as a watt. Do a thought experiment. Of course, you can go and do this on any flight of stairs. But think, if you walk slowly up a flight of stairs, you do a certain amount of work, W equal to delta EP, which is mgh. If you run up the stairs, you do the same amount of work in a smaller amount of time. Your power output is more. Here is a worked example using the definition of power. A large freight container with a mass of 3,000 kilograms is lifted to a height of 20 meters from the harbor to the deck of a large freighter. Calculate the power of the crane if it takes 2,5 minutes to move the container onto the deck of the ship. To find the power, we need to find the work done and divide it by the time taken. The time taken is 2.5 minutes, which we must convert to 150 seconds. The work done is mgh, and when we've substituted all those values, we get a power output for the crane of 3,920 watts. Power can also be calculated in terms of the applied force and the velocity at which an object is traveling. This formula is derived from the power formula by substituting the work equation and then replacing this fraction delta x over delta t with the velocity. So power is equal to force times the average velocity. Here is a worked example using the derived formula. A car with a mass of 1,200 kilograms moves at a constant velocity of 15 meters per second up an incline forming an angle of 20 degrees to the horizontal. The road exerts a frictional force of 620 newtons on the car. Calculate the force the car's engine produces and calculate the power of the car's engine. To find that applied force, we're going to have to do a vector sum with F net equal to 0 and then multiply by the velocity to get the power output of the car engine. Here is the solution. Here is the vector sum equal to 0, into which we substitute the negative frictional force of 620 newtons down the slope, and we can determine the negative component of the gravitational force. We complete all the substitutions and calculate the applied force to get 4,642,16 newtons. We multiply that by 15 meters per second, and the power output needed to maintain this speed is 69,632,40 watts. If we write this value in scientific notation, we would write 6,96 times 10 to the power of 4 watts, which satisfies the examination requirement of at least 2 decimal places. Now it is your turn. If you have the 3-in-1 study guide, you can try exercise 10, question 1 on page 161 and question 40 on page 177. The answers are on page 169 and 186. From the 2-in-1 study guide, we have questions 61 and 62. In question 61, language is important. A model car, mass 3 kilograms, has a powerful electric motor, marked 600 watts. What that means is that engine can do 600 joules per second of work, of which 363 watts is used to accelerate it from rest for 2 seconds. What that means is that only 363 joules per second are converted into kinetic energy as the car accelerates. This 363 watts is the rate of net work done. We have to define power in words, calculate the amount of energy transferred during the 2 seconds, and the velocity at the end of the 2 seconds using energy principles. In question 62, there is no acceleration, so no change in kinetic energy. But there is an increase in potential energy, and some energy is lost to friction. So the engine of the truck has to provide enough energy per second to balance out these other energy transfers. Calculate the height h reached by the truck at the top of the road and the instantaneous power delivered by the engine of the truck, and then write down some features of arrestor beds. Pause the video now to try these problems yourself. Then play the video and compare your answers to the model answers that follow. Learn this definition off by heart. It is included in the exam guidelines of 2014. Here's the power formula, rearranged. Substitute for the 2 seconds, and the work done is 726 joules to accelerate the car. We can equate that net work to the change in kinetic energy. Once we've done all the substitutions, we get an answer of 22 meters per second forwards. In question 62, there are 2 non-conservative forces that together contribute to the changes in kinetic and potential energy. We have the positive work done by the truck engine and the negative work done by the friction. Together they are equal to the change in potential energy, as the kinetic energy is unchanged. Once we've done the calculations, the unknown height turns out to be 6,28 meters. Alternatively, equate the net work to the change in kinetic energy and include the work done by the gravitational force. The angle between the height and the gravitational force vectors is 180 degrees. So the work done by Fg is negative and the height equals 6,28 meters. Since we already know the work done by the truck, we can use the definition of work to find out that the force is 3,04 times 10 to the power of 4 newtons. When we multiply that by the velocity, we get the power of the truck, in other words, the amount of work done every second on its way up the hill, to be 1,69 times 10 to the power of 5 watts. Arrestor beds increase the friction, and so they slow down a truck if its brakes fail. The oldest arrestor beds I know of in South Africa are outside Pietermaritzburg in KwaZulu-Natal. A series of accidents involving failed brakes convinced authorities to build these giant sandpits. They have to be long enough for the friction to do enough work over their length to bring the truck to a halt.
If you found this video useful, give it a like and subscribe to our channel so you don't miss any new episodes. Follow us on Instagram or Facebook to stay on top of the latest TAS news and launches. So that's it for now from the Answer Series, your key to exam success.